Ready, set, go. Hey! Congratulations, sir. Welcome to the next talk. I'll get this to you in a second. Welcome to the next talk. We have a couple. Oh, fuck's sake.
Yeah, I guess that thing is no good.
Later tonight, don't go anywhere. We have a big banquet dinner and diplomacy party. Read all about that in your programs. If you're doing the room, you probably should have got a call by now to go and burgle the room. All the contests are still running. All the vendors and sponsors are outside. We have some swag if you want some more Tinder swag, Hackaday swag, all that kind of stuff's outside. If you are doing the demo party, you need to have your entry to ARCO within the hour. So while you're listening to Sam's wonderful talk, finish up your demo, get it to ARCO. If you are doing ham testing, that is at 6 p.m. in the executive room right across the hall here. So if you're doing that, make sure you're there on time to take your test. Other than that, enjoy Sam Bound with how to Trojan financial Android apps and SSL validation failures.
What should I do? Here's this one?
Yeah, I suppose. So, I know Sam will tell you about this a little bit, but there was some controversy over this talk, and I was really looking forward to our first DMCA takedown rejection. I was going to
That would be fun, yeah.
Tell them no.
Yeah, well.
Take it away, Sam.
All right, thank you. All right, I'm suspicious of this thing. Let's see if I can attach it to me. Can you hear me?
Yes.
Okay, well, you can hear me. That's all that matters. All right, well, I have a few slides and then a lot of demos. All right, so I taught a mobile device security class for the first time ever, going through hacking mobile devices, and I had to apologize to the students for quite a lot of it because what's in the book is all fiction. There's plenty of secure practices well defined, and app developers just completely ignore them and don't do any of it. For example, OAuth. OAuth is a fictional product that makes it possible for as an app to authenticate to some service like, say, Twitter without handling the Twitter password, but nobody uses it. They all blast right through, they handle the password and throw it on the ground where you can steal it. I can't find any example of anybody actually using it. I don't know why they bothered writing it, but maybe for some future generation of people that care more about security. So anyway, Android is number one because it's cheaper. It is much, much less safe than iOS to an outrageous extent, entirely because of decisions made by Google to keep it free and open, and that makes it free to do stupid things you really shouldn't be doing, and they happen a lot. So, for example, apps have to be signed, but they don't have to be signed with a real public certificate. You can just sign them with a self-signed certificate, so what was the point of that? I could even download somebody else's app, take off their signature, modify it, and put on my self-signed signature, and it goes right back on. Now, if you leave the original app on, it'll say, hey, this new app does not appear to be a proper update of the previous one with the signature signing. You'll have to uninstall it first. Okay, well, that's all fixed then. So now Google has an official app store, but they don't actually keep bad things out of the app store very well. They've been humiliated with a series of disasters so that they're forced to be a little tougher every time about policing the app store. But, you know, I'm just guessing, you know, sort of like it's a religious issue. Why does Google do what they do? But, you know, it seems to me like they started with an open source ethic, that you should just be able to do anything you want. And they're very reluctantly moving over to Apple's position where you should be like a child playing in a walled garden where your parents keep all the bad people out, which is a whole lot safer, of course, for most users. So the Android debug bridge lets you debug your device and send data back and forth. It's very nice and makes it possible to push things onto the app, onto the Android device, pull files back from it, observe the logs. Anything put in the logs might as well as be published on the internet. I mean, perhaps I've exaggerated a little bit, but it's available to every app on the device and available to the computers connected to the device. So one of the fundamental rules of Android security is never log sensitive information. You'll be hearing more about that. You can install things. You can open a shell on the mobile device and just execute Linux commands, which is fun. Now, an Android app is an APK file, which is just a container with a bunch of files inside it, and you can do static analysis on it far easier than Windows binaries. Windows binaries, when you decompile them, they turn into assembly language, which is relatively difficult to understand, but this stuff turns into Smalley code. And all you need is this APK tool, a free open source product. So I give my students homework to play with this, to adding Trojans to an Android app. So you just run this thing, and it does its magic and turns this thing into just a whole bunch of little objects. And here's TD Ameritrade, a financial stock trading app. It disassembles, and I see all their source code. And you might notice this is really friendly. Consumer API, build config, account manager, base, cash manager. There's nothing to stop me totally reading their code. All the names of variables and such are easy to get. Now, Bank of America uses the standard obfuscator called ProGuard, which is built into Android suite, Android developer suite, and it's completely useless. ProGuard is like a security guard that locks half the doors and then goes home. As you can see, all these things are still readable. It took some of them and just turned them into A, B, and C, and I left a whole bunch of them just alone, like activities, enrollments, business credit card details, activities, just sitting here while the rest is like BR, BS, BT. So it does remove some of the names of the files and change them, but it leaves the variable names readable, so what was the point of that? And all the important functions keep their original explanatory name. And you might wonder, how bad is this Smalley code? Well, Smalley is Dalvik bytecode. And so here's Java, and here's the Smalley it produces. So if parameters put username here, put password there, it turns into username and password. It's really not a whole lot harder to read than just Java. It's a little bit strange. One thing you have to get used to is that you only have 16 local variables, and the local variables are called V, and the parameters are called P, and they come at the end, and they count against the total. And some apps actually use 32 of them, but the second batch cannot be used directly. You have to keep copying down to one of the first 16 to use them. But you know, 90% of the time, everything you might want to do to take over the app doesn't really require understanding much of that. So I learned how to do about 3 things in Smalley, and that's it. Now I own the world. So then all you got to do is recompile your app with APK tool. You build it instead of taking it apart, and then you sign it with your self-signed key, and now you can just put it back on the phone. So if you do, now, like I say, you should never put anything sensitive in the log. So you can monitor the log with a GUI tool, Android Device Monitor, and see things appear in the log. But it's a whole lot easier to just do from a command line with ADB logcat, because then you can use grep to filter all the log events and finds the ones you like. And so here I am looking for VFY or verif. This is actually very interesting. This is one of the very few successes from the work I'm talking about today. This is one of the people who actually patched their app. There are 3 or 4 of them, which surprised me, because most of the people I reported this stuff to would not talk to me, and the ones that did talk to me did not patch the app. But over the last couple of days, I said, well, before I give my talk, I ought to see if anybody listened, and a few of them did actually patch their stuff without telling me anything. So I'm kind of pleased to see that. They aren't all just ignoring it like I thought. So if you want to attack an app by decompiling and disassembly, you insert anything you want. Trojan code like keyloggers, you can find out what encryption method, you can do anything you want. And I learned a lot of this from Dancing with Dalvik by Thomas Richard. I saw him at B-Sides, and he showed us how to cheat at games with Dalvik. And I said, hey, this is actually pretty easy. And I don't do anything hard. Nothing I do can be any harder than about a 2-hour homework assignment for my students. So that looks pretty doable. So here's how you take over the Bank of America. So you start with the Bank of America app, install it on an Android device, then you use these commands to get it back from the device so you can play with it. This is the shell command that lists the packages on the device, and then I use grep to find the B of A, so it has this funny name, com-info-now B of A. Then I use shellpm path to find out the exact path to the APK file, which is the single file that includes the entire app, and then I just pull that file down, so now I have it on my computer. Now all you do is use APK tool to disassemble that app, and what that creates is this whole tree structured mess. And let me just bring it up live here. So I have done this, of course, and I've redone it all over the last 24 hours to check for updates, so it's gotten pretty fast. FinApps is the folder where I put all these things, because originally I focused on financial apps. And here's the latest one, Bank of America 5. I did this to decide whether to do it live during the talk, and it took 10 minutes in my hotel room, so I decided to only talk about this part of it rather than trying to do it live. So this is the APK file that comes down. When you disassemble it, you get this folder. It has a few XML files, so you can control the structure, and a lot of files that are going to end up in here, but all the code is in this Smalley directory, and you can see what they've done here. B of A wrote some custom code here. They have some Android libraries here. And then there are coms and orgs involved. If you go to com, various different people have contributed to this code. They've used libraries, and they're all in here. Here's the custom stuff they wrote, e-commerce. And in particular, let me just find the one that's fun to Trojan here. I'll just go to this stuff live. Everything I'm going to show you is, hey, it's on that website, which is not loading because of the hotel Wi-Fi. There it goes. It's all down here. Here's all the security results I'm going to report today. This is the landing page that leads to all the rest, and if it's going to load slow, I'm just going to look on my slide where I've got it. See, you can search for this stuff with grep. I wandered around. Usually I look for password. If that doesn't work, I look for user agent, user ID, and a few other things. And if that doesn't work, I just start wandering through the routines, looking at things. And when everything fails, I wrote a tiny little Python script about 10 lines long that Trojans every module in the whole app. So it runs slow, and the log just screams. And every single routine that loads, it puts out a log message to every single app, every single module it runs. And then I get to the login screen and start logging in and see what runs at that point to try to find what part is likely to have the credentials. Anyway, this one here was small ecom, B of A, ecom, off, activities, enrollments. So anyway, I think I'll just stick to the slides for this one. So you see golfing enrollments. Here's the file, business credit card details activity. That's the one I found that handles credit card numbers, and I thought those might be fun to steal. So when you look at the code, this is what it looks like. Now this is the glorious obfuscator. The function is now named L instead of whatever its original name was, but the string is still called B of A. Oh, that's the one I put in, pardon me. But this here is still called set card number. That's how I found it. So this is all the Smalley I know how to write. Well, I know slightly more than this, but not much. I changed the number of local variables, so I have another one to work with. So before it was 3, so it only had V0, V1, and V2 are the only variables you can use in this routine. And I don't want to step on one of those and change it so it'll break, so I changed it to 5, so now I can use V3 and V4 with impunity. And in fact, I ended up using V3. And here's the main Trojan I always use. The only thing I figured out how to do, I forget why, maybe I copied it from some blog or something, but you can make a constant string and you can put it in the log with this. This makes a log that has, this is the name of the item and that's the value of the item. So I figured this thing in V0 is a string. And it looks like it has something to do with the card number. So I just want to see what it is, so I put B of A Trojan card number right there, put out V0. And I want another one down here that says set CVVs. That sounded pretty good. So I dumped that one out. And that's it. The only thing I've learned about Smalley is that when you see a function like this, the result goes in the one on the right. Anyway, so that's the game of that. Now you rebuild the thing with Java jar, and then you sign it with a self-signed key, which is just canned routines. By the way, APK tool often gives you a screen full of error messages when tearing things apart, and another screen of error messages when putting it back together. And I've always found you can just ignore those and everything's fine. I don't know what they're all about. I thought somebody actually fixed something the first time that happened, but no, it complains about ping files a lot, but everything seems to work. So let's play with this thing. It's easy to see what it does. So I got all these apps here we're going to play with. Let's get the log up. ADB logcat. We'll start with this one. Okay, this shows you everything that's going on that Android device. And when I launched the Bank of America app, it has a whole bunch of junk going by, which is kind of irritating to see all this junk happening. So I'm going to filter it for the word Trojan, because this is the Trojan one. And the hotel Wi-Fi will hopefully knock off being so slow. Let's see if this page ever loaded. All right, if it's going to be like that, let me see if my phone's any better. All right. In fact, I've learned from experience that the USB works a lot better than the Wi-Fi on the phone, because I think a lot of these slowdowns are local Wi-Fi interference. Did, all right, well. All right, I will use it, but I'm keeping the phone around to scare it into submission. So, no, it didn't. All right. So let's connect through my phone and see if it's any better. This is a common problem in hotels. That's why it's nicer to give talks at colleges. But they don't let you have any booze. But we've had the first B-sides with no booze in San Francisco, and there was not a riot like I thought there might be. So we may be able to move towards colleges, which would suit me better. All right, let's see if I actually get any better joy out of this thing now. I don't care about your stinking iTunes. Let's see if I can get on the internet yet. That's a bad sign. Trust this computer. It's not the right question. See if I can get any kind of internet service here. That's not a good thing. Off. On again. Oh, I see. I don't even have 3G or anything in here, do I? All right. Apparently, I must attempt to use the hotel Wi-Fi. Is there anything that works? Yeah, if you got anything that works, I would like to use it. Because my phone is not getting any signal, and the hotel Wi-Fi has quit working too. It worked when I was in the audience, but not up here. So what do? Just choose a wireless network of some sort? Well, that's the credentials? Good, good. Let me turn on my Wi-Fi. Let's see. Thank you. Copernicum. All right. I should be able to see it. Let's see. Well. It says it's looking. There it is, Copernicum. Good. You want to type in the password? Why not? Good. You're a champ. And I won't retrieve that password from the machine. Now that's a password, all right. Yeah, that's pretty impressive. All right, thank you. Let's see if I can get on the internet now, without which things are no fun. Now what is this? I'm still not on the internet? Oh, now I'm on the internet. Ah, good. Thank you. All right. Ah, good. Retry. Yeah, looks like it. Aha, something happened. Life is good. All right, so here we are. We're glorious. Now we can enroll in banking. That's what I want to do. Get started with a small business credit card. So here's my credit card number. And I've got a month and a year, and I got a CVV, and I got a social security number. And when I continue, there they are. They all just get jumped in a log because this is a modified app. And this thing is communicating with the Bank of America servers cheerfully and stealing the data as it goes by because the Bank of America just don't care. It might be worth mentioning that I told them about this in February and got no answer at all. All these people have known since February or March. And most of them don't respond at all when you talk to them. And the ones that do just make promises that don't come true. So let me try the Bank Corp. I chose these to show you different categories of Trojans that I made that I thought were interesting. Bank Corp is an interesting case. In Bank Corp, they used something called the Secure UI module, which meant that this kind of Trojan wouldn't work. They don't actually load the password in a single variable that I could find, but I can catch the keystrokes. 1, 2, 3, 4. So that'll do, really, to prove the point. Yeah, all right. And let's see, next one was, there were 4 different categories of all the ones I did. Capital One, I forget what was different about this one. Let's see. I can tell from the slides, I think. Yeah, Capital One, yeah, that's right. Capital One's what it showed you. Capital One uses Google Cordova, or Apache Cordova, whatever in the world that is, some developer might know, and it catches the keystrokes here. And by the way, both of these irritated me so much, I had to just Trojan everything, and then I noticed the same thing would run every time I hit a key. I said, okay, I'm going to that thing. So now when I go, let's bring the log up. Okay, so now when I bring up this user ID, it's going to be flapjack, and the password is password. Okay, you're getting these key numbers. Now those key numbers are not ASCII. They are some nonsense Google made up. And they put them on a page that I can find where they have like 1 per page for 255, and you have to scroll down and sort of put them back together. But anyway, it is possible to turn those ridiculous things back into letters like this, 29, 30, 31, and so on. The password is included in that nonsense. It's just in a slightly irritating manner. So it does sort of prove the point. And of course, if I just added any code and then recompiled it and it ran, that would be enough in principle to prove that the developers made a serious error. They should have validated their code. But this is, as far as I can tell, my entire contribution to this business is theater. The point is you have to impress people. And they won't care if you have some theoretical problem. They want to see you really stole the credit card number. They can understand that. That's why I always try to make where you really get something real. So SunTrust, I was not going to test SunTrust. I was working from the top 10 banks I found in like a US News and World Report article or something. But I put some of this information on Twitter, and somebody said, did you try SunTrust? And I thought he was a SunTrust executive. So I tried SunTrust, and it turned out he was just a SunTrust customer. But anyway, SunTrust turns out to be both important and interesting. So let's take a look at SunTrust. And they're friendly too. These guys responded when I reported to them, and their security officer talked to me and he said, oh yeah, that's important, we'll really fix that, but we're not sure when. And I don't know when either, it hasn't happened yet. But he said it's not under current active attack, which is an interesting point of view because this was all under active attack in 2011, but maybe they have moved on to other things now. Anyway, so here's SunTrust. My user ID is user, come on, okay, user ID. My password is LayerOne. And I log in. And here's what SunTrust gives me. It puts them all over the place. What I had to do was Trojan all the parameters being set out the network. Here's the layer 1, here's the name, here's the password, and the user ID. What I did here was Trojan the routine that creates HTTP requests and sends parameters out. That's why there's all this other junk. This is the value and name of every HTTP parameter being set up. But it's good enough to catch it. And so the only thing that makes this difficult is that many developers include many routines they don't use. So when you grep for password, you find 100 of them, but only 2 of them are actually used. All the rest are legacy code they brought in and didn't bother using. Anyway, so that's the game there. So TradeKing is the one I wanted to show you. TradeKing is one I found out yesterday actually patched their app, which caught my attention because it's interesting. So let's go back to just a plain old logcat here. So we're seeing everything happening on this device. I go back here and run TradeKing, which is some kind of stockbroker trading activity. And by the way, when things crash, oh yeah, that's right. This one actually means it when it crashed. This is the Trojan app, and it won't launch anymore. It used to. And if you want to know why, you can see right in the log, right here, runtime exception, this log, let me just do it again. Fatal exception, there. Fatal exception, comms echo mobile activity login. And up here, we're going to see verifier rejected class login. And that's where I put the Trojan. So what these guys have done now is they put in some kind of verification of their code that notices that this module has been altered and refuses to start. And that is exactly what I told them to do. I said you should validate your app. Now I thought they would validate the signature, which it seems to me would do the whole thing, but they didn't do that. They validated the code. Now, I don't know how they did it. I just found out about this a day or two ago. I wouldn't be surprised if the verifier itself is somewhere in there and I could find it and turn it off. But still, I still regard this as progress because that's all security ever is. The cops get bigger guns, the crooks get bigger guns. I mean, they made it harder. That's all you can ever do. Then it'll slow down people, and there are probably maybe more perfect solutions, but at least they did something, which I appreciate. So let me see if I can get my general summary page up here. Oh, here we go. So this is the first. Now, what I'm doing here is talking about known vulnerabilities. On Twitter a couple months ago, I called these things 0 days, and they already yelled at me. They're not a 0 day, they're using the same old principles. They're right, not a new principle, just vulnerabilities that have not been patched. This one is M10, lack of binary protection, where you can modify the code. So that's the first one I looked into here because basically every app has it. It was something like 8 out of the top 10 banks, 9 out of the top 10 stockbrokers, 7 out of the top 10 insurance companies all had this problem. So it is something like 80 or 90% of all apps are vulnerable. And here they are, the Bank of America, Bancorp, Capital One, Chase. The ones in green have actually fixed it. M&T and Wells Fargo. Wells Fargo probably because one of my students is like close to the head of security there and was able to make a personal plea, I think. SunTrust promised to fix it. One thing that was kind of entertaining was Charles Schwab. So Charles Schwab was vulnerable to this. And when I tried to contact them, it turned into a real circus. Oh, by the way, one thing I wanted to make sure and mention here, which I think is a really bad idea, is that absolutely none of these people have any vulnerability reporting process, far from bug bounties or anything. there is not even any address to send anything to, and if you send security@company.com, it just bounces, with a very few exceptions. So they're so far back in the dark ages, they're pretending that they have no problems and they don't need to hear from us, which is an unwise place to be. And anyway, there are a few exceptions, but anyway, Charles Schwab is notably not one of those exceptions. So I Trojaned this Charles Schwab app, and then I tried to tell them. They have an email form, which is just broken. An error occurs when sending an email. Then I send email to security, but that just bounces, of course. Then I found another email form at the UK office, which doesn't work either. So then I sent to the international office at Schwab, and I was able to send an email that didn't bounce, but then I found a website that says there's no point emailing Charles Schwab, they ignore everything that comes in every email address, you're just totally wasting your time. So I switched to something which I have done several times with great success, which is you look up the CEO on Twitter, and then you tweet him, please follow me. I have actually never failed with this approach. I don't like it because it's tantamount to full disclosure of public vulnerability, because I'm not willing to bother CEOs over nothing frequently to create background noise. If I ever tweet a CEO, anybody can guess exactly what I have to say. And that's, of course, what happened. Swift on security, of course, figured out what I was saying and told. So, you know, so this is not good operational security, you know. But I've never had it fail. The CEO does get back to you right away, and this is a fundamental rule I've learned about vulnerability disclosure years ago, which is the person that created the problem will never fix it, or usually even admit it exists. Although I have one counterexample coming up later. Anyway, so he contacted me, and he put me through to their security team, and they sent me through to the right person, and he said, oh, for God's sake, if you find something else, don't go to the CEO again. So I did find something else last week, and I sent it to him, and I didn't get any answers. So we're going to see how far that goes. But anyway, they also did not fix their stuff. Charles Schwab is still vulnerable. All these trading apps are vulnerable. And TradeKing, however, is one of the few that did fix it. And here's the others, Wells Fargo and MT Bank. Those are the only three people that actually fixed an app. Now, you'll notice down here in insurance companies, Geico and Intuit TurboTax get yellow because they didn't fix anything, but they do have a page to report vulnerability problems in. Geico has a very nice page, as are you a security researcher, as if they understand what we are, but then when I tell them, they ignore me and do nothing. And one of them, I think it was Geico, actually promised that they would have it out in the May update, but then they just didn't. And then I talked to their security guy again, and he said, oh, the team told me they were going to obfuscate the code. And I said, you don't have someone test? Well, you know, it's not hard to test. Everything I know I learned from that book, and my students do it for homework. I mean, I didn't get rude discussing with them, but, you know, it doesn't seem to me like I should need to tell somebody in that position that when you tell an employee to do something, you then have to test to see if they did it. But anyway. All right, let me go back to here, because there's more categories of trouble to talk about. So anyway, like I say, one defense that a lot of people told me is this doesn't even matter, Trojan's not really ever going to happen, you're just making it up, it's not a realistic threat, and I don't think so. Because remote place, now you might reasonably say, see, if this was an iPhone, none of this would happen, because you have to install things from the store, and Apple actually polices the store. If you put a Trojan app in the store, you get kicked out, just ask Charlie Miller, and they're not messing around. Android just doesn't do much of that. They don't clean the store very well, and people install stuff that's not from the store. But if everyone was required to install things from the store, then Google could control this, but they're not very interested in doing it. Now, they did some of it. They took out the Droid Dream ones that were Trojan in 2011, but their application verification service is just fantastically ineffective. This is how effective it is compared to all the other antiviruses. The bouncer thing is just not very successful. Anyway, you can protect yourself here. One thing you can do is obfuscate your code so it's very hard to read and find where to put the Trojan, and that